Hello friends, I welcome you in lecture number 36 on logic. From this lecture onwards, we are going to discuss about rules of inferences for propositional logic, and then after we will discuss rules of inferences for predicate logic. Now we are familiar with propositional as well as predicate logic. So whatever we have learned up to lecture number 35, we are going to use all those stuff in this topic of rules of inference. So before going for rules of inferences, first we try to understand some terminology required to understand these rules of inference. So first we understand the meaning of these two words, argument and argument form, and for that we start with one example and then we will see what are the definitions for argument and argument form. We are familiar with argument in English language, but here we are going to define argument in terms of this mathematical logic. So we start with this example. I have taken this example to explain the meaning of argument and argument form. So here we can see we are given three propositions or statements. Now we are familiar with the definition or meaning of proposition. Proposition is a declarative sentence which is either true or false. So here there are three propositions. This first proposition I denote by P1, second I denote by P2, and this last proposition I denote by Q. So you can see here I have, if you have a current password, then you can log on to the network. Second proposition is you have a current password, and last one is you can log on to the network. So here I have three propositions which I have denoted by P1, P2 and Q. So we can say that this is a sequence of three propositions P1, P2 and Q, and this is example of argument. So argument, the structure of argument is we will have sequence of propositions or sequence of statements, and these two propositions or statements are called premises, and last proposition is known as conclusion. Whenever we are talking about argument in this sense of this mathematical logic, then argument is nothing but sequence of propositions, and in that sequence last proposition is called conclusion, and all the previous propositions are called premises. So here we can see the argument is that if you have a current password, then you can log on to the network, and second proposition is you have a current password. So from this can we conclude that you can log on to the network. So we are interested in the validity of this argument, whether this argument is valid or not. So whenever we have some argument, then that argument is valid if whenever all the premises are true, then conclusion is also true. That means in this case, whenever P1 and P2 both are having truth value t, and if that implies that this conclusion is also true, then we will say that the argument is valid. So that is the meaning of validity of an argument. We again recall that what is argument. So argument is a sequence of propositions in which last proposition is known as conclusion and all other propositions are known as premises. Now when our argument is valid, so our argument is valid if whenever all the premises are true, then conclusion is also true. The argument is valid if conclusion is true whenever all the premises are true. So in this topic of rules of inference, our main aim is to check whether given argument is valid or not. So for that we have two methods. One method is using truth table, and second method is we are having certain simple arguments whose validity is known to us. So they are known as rules of inference. So using rules of inference, we are able to determine whether given argument is valid or not. So first we for this same example, suppose we consider that this is denoted by P. This proposition I denote by small p. That is, P denotes that you have a current password, and suppose this is denoted by Q. That means you can log on to the network. So this first proposition P1 can be written as P implies Q. Here we have conditional statement. If you have a current password, then you can log on to the network. That is, in symbolic form is P implies Q, where P is you have a current password and Q is you can log on to the network. And here you can see this P is repeated here, you have a current password. So this is denoted by small p. And what is this? You can log on to the network, that we have denoted by small q. So you can see this argument in symbolic form is first proposition is denoted by P implies Q, second proposition or premise is small p, and conclusion we write here, conclusion is Q. So we will use this type of notations to denote the form of argument. If this P and Q are arbitrary propositional variables, then this is the structure of argument form. Here I have premise P1, this is premise P2, and this is conclusion which we have denoted by Q. So above this horizontal bar we are writing all the premises, and conclusion is written below this horizontal bar. And this is for this particular argument we have used these notations, but we can consider P and Q as arbitrary variables, propositional variables, and then this structure is called form of argument or argument form. So this argument in this example is having this form of argument or this argument form. Now when this is true or when this argument is valid, so this argument is valid whenever these two propositions are true, implies that this is also true. That is, if P and P implies Q, these two propositions are true, implies that Q is also true, then we will say that this argument is valid. So this we can check using truth table. We can prepare the truth table for P, Q and P implies Q, and then we will search for rows in which these two are true, and we will check the corresponding value of Q. So that we can understand, here I have written this as an example. Suppose I have written here, I have written P implies Q and P. If I wish, I can write in this way also. I can write P implies Q first and then P and therefore Q. So this is argument form, and I want to check whether this is true or this is valid or not. This argument form is valid or not. So for that I will prepare the truth table. I know that this argument form is valid if whenever these two are having truth value t implies that this is also having truth value t. So if this happens in all the cases, that is conclusion is true whenever these two premises are also true, then in that case we will say that argument form is valid. So for that, first we write down the truth table. Here I have two propositional variables, so I know that different possibilities for their truth values are, here I will write alternately true and false. And this is conditional statement. We know that P implies Q is false if P is true and Q is false. In all other cases, it is having truth value true. We again repeat that this implication is having truth value f whenever P is true and Q is false. So in first case, P is true and Q is true, therefore this is true. Here P is true and Q is false, therefore this is having false truth value. And here there is no truth, here P is false, so we don't worry about Q, we write down simply true. We know that P implies Q is false whenever P is true and Q is false. In all other cases, it is having truth value true. So this is the truth table. Now I will check that whenever premises are true implies conclusion is also true. That means I will search for those columns for which premises P and P implies Q are having truth value true. We know that argument is valid whenever conclusion is true if these two are having truth value true. So now we will search for every row. Suppose I give these numbers 1, 2, 3 and 4. These are the numbers for rows. So I will search for those rows in which P and P implies Q both are true. So in first row P is true, P implies Q is also true. So I have to check whether Q is having truth value true or not. So we can see that in first row P and P implies Q both are true, then Q is also having truth value true. So this is the first possibility in which both the premises are true and conclusion is also true. Now we check whether there is any other row in which these two are having truth value true. So in second row P implies Q is false, so we don't have to check. In third row P is false, and in fourth row also P is false. That means these two premises are true in first row only, and in that case Q is also having truth value true. So this means that whenever these two premises are true, that implies that Q is also true, therefore this argument form is valid. So that we have to write systematically. Here I have written that P and P implies Q are true simultaneously only in first row, and in this case Q is also true, therefore this argument form is valid. Now there is another way also to show that this argument is valid. What we have shown here, that P and P implies Q are true and therefore Q is also true. Another way of writing this is that here now we know that whenever these two are true, therefore Q is also true. Now when P and P implies Q are true, then we know that their conjunction is also true, that is P and P implies Q is also true, and that must imply that Q is also true. So if we can show that this implies Q is a tautology, then also we have shown that our argument is valid. So whenever some argument is valid, then if we take conjunction of premises and if that implies Q is a tautology, then also argument form is valid. So sometimes they can ask you to prove in this way also, prove that P and P implies Q is a tautology. So both are having same meaning. We know that this is true if P and P implies Q are true, implies Q is also true. So in that case this will become a tautology. So now we know that this argument form is valid, that is whenever P and P implies Q are true, implies Q is also true. Okay, we understand in this way that these two premises are true, implies that Q is also true. So if our argument is in this form, then we can say that that argument is valid. Here this P and Q are propositional variables. So if we take particular values for these propositional variables, or if we take particular statements for these two variables, and if they are having this type of argument form, then using this we can say that our argument is valid. So this is called rule of inference. So we are going to have certain rules of inferences, and using those rules of inferences we will be able to determine whether our argument is valid or not. Whatever argument is given, for checking its validity, we will try to see that that argument is in which form, and we will remember this type of particular forms, and using those rules of inferences we will be able to determine the validity of a argument. So what we have seen here, that if our argument is in this form, that is if P and P implies Q are both true, then Q is also true. So this is special type of rule of inference. It is known as Modus Ponens. Another name is Law of Detachment. Law of Detachment or Modus Ponens. So this is very important rule of inference, Modus Ponens, which says that whenever these premises are true, implies Q, or whenever our argument is in this form, then our argument is valid. Or this says that whenever P and P implies Q are true, then Q is also true. So we will remember this form of argument, and using this form, if our argument is in this form, then we can check its validity. So remember, this is the first rule of inference known as Law of Detachment. Another name is Modus Ponens, and we will remember that if P and P implies Q are true, then Q is also true, and it is easy to remember. Here we can see P is repeated 2 times, and here I have Q. So here I will write Q, I will not write P. Now we come back to our previous example, and we can see that this argument is in that form. Here I have P. This first premise is P implies Q. Second premise is small p, and now this is in the form of law of detachment or modus ponens. So using that rule of inference, I have therefore Q. What is Q here? Q is you can log onto the network. So we now know that this argument form is modus ponens, and it is valid for any value of this P and Q, and this argument is in this form of argument. therefore this argument is valid. So there are two ways to check the validity of argument. First one is using truth table and another one is using rules of inference. And we have seen first rule of inference, which is known as Modus Ponens, and it says that whenever P implies Q and P are true, then Q is true. So if our argument is in this form, then using this law of detachment or modus ponens, we can say that our argument is valid. Another way is using truth table, but truth table is not advisable every time, because sometimes if I have three propositional variables in our argument, then I have 2 raised to 3 equal to 8 different combinations for their possible truth values. So in that case, using truth table will make our work tedious. So instead of that, we will use different rules of inferences. And first rule of inference we have discussed is modus ponens, and we will be discussing another rules of inferences in upcoming lectures. So we stop this lecture by just reading these definitions. Sometimes they can ask you to write down the definition of argument formally. So here I have written, an argument in propositional logic is a sequence of propositions. All propositions except final are called premises, and the final proposition is called the conclusion. And argument is valid if the conclusion is true whenever all the premises are true. So this is the meaning of argument. Then I have written the meaning of argument form or form of argument. Argument form in propositional logic is a sequence of compound propositions involving propositional variables. So if our in the argument, if we have this P and P implies Q, these are propositional variables, then we will say that we have form of argument or argument form. And whenever we assign particular values to these propositional variables, then we will have argument. Now an argument form is valid if no matter which particular propositions are substituted for the propositional variables in its premises, the conclusion is true if the premises are all true. So argument form is valid if whenever P and P implies Q are true, implies Q is also true, and this is true for any value of these propositional variables. Here that is emphasized here, no matter which particular propositions are substituted, the conclusion is true if the premises are all true. And this is another way to show that argument form is valid. If I have n premises denoted by P1, P2, Pn and conclusion is denoted by Q, then this argument form is valid when P1 and P2 and so on and Pn implies Q is a tautology. We can always use truth table to show that an argument form is valid. We do this by showing that whenever the premises are true, the conclusion must also be true. So if we are using truth table, then after preparing truth table, we will search for those rows in which all the premises are having truth value true, and then we will check the corresponding truth value of conclusion. So that I have written here. We can first establish the validity of some relatively simple argument forms, and they are called rules of inferences, and I have discussed one rule of inference that is known as modus ponens. And these rules of inference can be used as building blocks to construct more complicated valid argument forms that we will see in upcoming lectures. So we stop this session by again emphasizing that this is the most important rule of inference known as Law of Detachment or Modus Ponens, and it says that if our argument is in this form, that is P and P implies Q are true, then Q, that is conclusion, is also true. So we stop here and we will continue with these rules of inferences in upcoming lectures. Thanks for watching.